Okay, today's lesson is lesson 4, recognizing functions by their characteristics. So here are our objectives. We want to recognize similar characteristics among function families, recognize different characteristics among the function families, determine function types given certain characteristics. And so let's talk about what we already know. We've already identified key characteristics of graphs. So how can key characteristics help you sketch the graph of a function? You can pause and discuss with your group. Okay. Key characteristics, when we know those, we know what linear looks like. We know that if they tell us it's a continuous and it's a constant, that we've got some kind of a linear function. And so we've got our straight line. We know that if we have an exponential function, that it is rising or dropping very rapidly. And it's going to be a curve. So it could kind of look like this, or it could look like this. Okay. But as we move left to right, it is a rapid rise or fall. Okay. And then you have your quadratics. So if they talk about having an absolute minimum or an absolute maximum, you know you have a quadratic function. So it's either going to have a low point or it's going to have a high point. Remember, this is your absolute minimum and this is your absolute maximum. So these are some things that you should have picked up on, hopefully from our previous lessons. Okay, we're going to go through some characteristics. I'm going to ask you to pause if you're doing this with a group and discuss and see which ones of the function families would apply to each one of these situations. We've got linear, we have exponential, and we've got quadratic. So you're going to read question number 1, which function families can be described by the characteristics provided. And you can choose more than one answer because more than one of them might work. Go ahead and pause. Okay, we're back. Let's see how you guys did. So the graph is a smooth curve. That's actually 2 of our function families. Remember, we have exponential that, either rises quickly or drops quickly, but it is a smooth curve. And we also have the quadratic, which is that U-shaped. That's a smooth curve. It could be either going up or down. Okay. Letter B, the graph is made up of a straight line. That's definitely just going to be linear. Okay. Could be rising or falling, but that's definitely linear. The graph increases or decreases over the entire domain. Well, guys, if you look at the pictures that I drew here, quadratic goes up and then comes back down. Okay. So it does more than one thing. Whereas linear, I'm sorry, I'm trying to get my pointer to work here. Linear and exponential only do one or the other. I'll get there in a second. So I'm going to point to some things here real quick. Okay, there now. Okay, so exponential, that one increases, decreases. Linear will either increase or decrease. So it could go up or you could have a line going down. But when you have a quadratic, it's either going to go down first and change directions and go up, or it will go up first, change directions and go down. This particular question says you got to do one or the other. You can't do both over the entire domain, which means as you're moving left to right. And so the ones that only go one direction are going to be linear and exponential, because remember, quadratics go 2 directions. They go up and down. Okay, this next term, the graph has an absolute maximum or minimum. That is a key feature of quadratics. So you either have a quadratic with a point up at the top, that's a maximum, or you have a quadratic with a point at the bottom, that's a minimum. Okay, all right, question number 2. One or more characteristics have been added to the graphical description of each function. Name the possible function families. So pause, see if you can discuss this if you're working with a group or working on your own. Okay, the graph has an absolute minimum or maximum. Well, that's talking about quadratic, and it's a smooth curve. So they've given us a couple of requirements. It has to be a quadratic function. Okay, the graph either increases or decreases, so quadratic is out, over the entire domain, and it's a straight line. Well, now we're talking about linear, because linear and exponential both either go up or go down, but only linear is a straight line. The graph is a smooth curve for C and either increases or decreases. Okay, well, this one is saying we either increase or decrease. We can't do both, and we need a curve. So that has to be talking about exponential. Okay, we're going to look at the function families, we're going to look at the scenarios that we did way back in lesson 1. So I'm going to actually skip this next page, and we're going to go all the way to the table on page 62, and we are going to look at these different these scenarios that they gave us, and we're going to discuss, first of all, the domain of the real world situation. What they want to know here is, should it be discrete or should it be continuous? Now, clearly, every one of the graphs that we looked at in lesson 1 was represented as continuous, not the dots. Remember, discrete is when you have the dots, and continuous is when you have a line with no breaks in it. But in reality, some of these really should have been discrete, because they have breaks in the data, and I'll explain that in a second. Now, the graphical behavior, I need to know, is it increasing? Is it decreasing? Or is it doing both? Okay, so let's start with the music club. Clearly, this one's increasing. So I'm good. That last column is easy to identify. Now let's talk about, should this be discrete or continuous? I want you to think about, this was about songs and dollars, okay? It's possible to buy 0 songs. It's possible to buy 1 song and 2 songs. But I want you to look at the part of the line segment that's in between what I just drew, these dots right here, these little line segments partial. Is it possible to buy 1.5 songs? Can you buy 2.7 songs? And the answer is no. You can buy 1 song, 2 songs, 3 songs. You can pay $1, $2, $3. There's no decimals in this problem. So really, this graph should have been drawn this way. It should have been drawn discrete. And really, I should just have the dots. So I'm putting dots in there for you to show that I can start at 0. You can't buy negative songs. I can start with 0 songs. And I can buy whole songs. And I can pay whole dollars. So this one should have been discrete. Okay. The next one, something's fishy. In this scenario, we had an aquarium, and we were emptying it out over the course of several minutes, and we were measuring how high the gallons of water was. And when it started, I think it started out with like 20 gallons of water or something. And over time, we were pouring the water out, and it's getting lower and lower and lower. Well, my question for you is, do I skip from 20 gallons to 19 gallons to 18 gallons? Or over time, is the level gradually getting lower and lower and lower? Is it possible to have 19.4 gallons in the aquarium after a certain number of minutes? And hopefully you can see that this is a situation that really is continuous, okay? That water is not jumping from one level to the next level. It starts at 20 and it slowly goes down, gets lower and lower and lower, and eventually it would get all the way to 0 after a certain amount of time. Okay, so it's continuous, and it goes from 0 minutes to however many minutes it takes to get it all out of the aquarium. And this is a decreasing graph. The water level is going down. Okay, smartphone. This is where we had our kind of crooked cousin, and our cousin was making us pay by the week. And we were paying him interest in dollars. And we start out not owing him anything, but after 1 week, we pay him something. At week 2, we pay him something. At week 3, we pay him something, and it doubles every time, okay? So at week 1, I think we pay him $1. Then we double it to $2. Then we double it to $4. And then it doubles to $8. And you can see we keep going up and up and up. Never do we ever pay him halfway through the week. And these little spots right here in the middle where the line segments are, we shouldn't have a line there because we pay him each week. So when you get to the next line, that's when you owe a payment. Week 0, week 1, week 2, week 3, and so forth. So this should not be a continuous graph. This should really be discrete because you're never paying him middle of the week. It's not like you're standing there just constantly giving him money. And this is an increasing graph. Okay. Next one, we've got our It's Magic. Now on this one, we have the magician, and he starts with a length of rope, and it is length in feet. And it starts out at 20 feet long. And down at the bottom, we're measuring cuts. So he starts out at 20 feet, and at the first cut, he's already cut it in half, which is going to put us at 10 feet. And at the second cut, he cuts it in half, which is going to put us at 5.5 feet. At the third cut, he cuts it in half. Now that's going to put us at 2 and a little bit, okay? Well, you don't make, we're counting cuts. As you're looking at the domain, which is your x-axis, we're doing 1 cut, 2 cut, 3 cut. You're not doing 1.5 cuts. It's always 1 cut, then the next cut, then the next cut. Hopefully you can see this is a discrete situation. That rope does not go from 20 feet to 19.9 feet to 19.8 feet. Doesn't do that. It goes from 20 to 10 to 5. It gets cut. It's jumps. So when you have jumps in your graph, we're not going to connect the dots. And this one is decreasing. Okay, let's see what you guys said about this next one. So we have our baton twirler that throws the baton up. We're measuring seconds on our graph. And up at the top, we are measuring height of the baton in feet. Okay, she starts at second 0. That baton does not jump from whatever height it is when she throws it out of her hand, probably about 5 feet off the ground. The baton does not jump from 5 feet to 10 feet to 15 feet to 20 feet to 22 feet. That doesn't happen. Time, when you're measuring it in seconds, this is continuous. And so that baton is gradually going up. It tops out and it gradually comes back down. It never stops. It doesn't jump levels. So this would be a perfect continuous. And this one is increasing. Then it decreases. Okay, starts going up and then it turns and comes back down. Okay, skateboarding guy is going to be the same thing. Okay, he starts high, he skates and goes lower, and then he turns around and goes back up. That is definitely a continuous. So this is an appropriate use for a continuous line, but this one decreases, it drops, and then it increases because he goes back up. Okay. In activity 4.2, I'm not going to have you come up with the graphs. We've come up with some graphs for you. I do want to show you what linear function looks like and what quadratic function and exponential function looks like. I want to point out something to you, okay? When you have a linear function, you guys learned this one last year, y equals mx plus b, or function of x equals ax plus b. It means the same thing. A is your slope. B is your y-intercept, okay? Notice there is no exponent. When you're looking at linear, there is no exponent. The exponents are going to cause us to curve, okay? Linear has no exponents, but when we introduce exponents, this is going to cause us to curve. The exponential function has an exponent of x. So if you see x is your exponent, you know that you're going to have one of these smooth curves that's either decreasing or increasing all the way across the graph, okay? If you have a quadratic function, quadratic functions always have the exponent of 2, and they always have that U shape, okay? So your quadratic is going to have an exponent of 2. Okay, and it's either going to be a minimum or it's going to be a maximum. I'll even go ahead and tell you, if that A right there in the front of the equation, if it's positive, it's going to be pointing up. If it's negative, it's going to be pointing down. Okay, so those are your basic clues to tell you what your graph is going to look like. So let's look at this very first one. They want exponential. So I know I have to have an x in my exponent. So I have written an equation with an x in the exponent, and I'm going to sketch it. And guys, we're not asking you to figure out how to sketch it on your own. Go type it into Desmos, and then you can sketch it. So I'm going to do f of x equals 3, and then I'm going to put the 1 divided by 2. Make sure you arrow out of the fraction to get out from under it. And then I'm going to use the A to the B button to put an X up there. And as you can see, this is an exponential function. It is decreasing. I'm going to go find my y-intercept. It looks like my y-intercept is at 3, which, by the way, y'all will learn this in later chapters, but I'll go ahead and just tell you now that whatever this number is in front of the parentheses, that's going to be your y-intercept. It's your starting point. So if I was going to graph this, and I'm going to graph this, I'm going to let this over here be my axis. And 1, 2, 3 is my y-intercept. So I've got my curve coming out like this, and it looks like this, okay? So this one is decreasing. You can see it's going down. You can see the y-intercept is 3. So I'm just graphing what I see. Okay, this next one, I guess maybe I should have drawn the x and y-intercept down the middle, or x and y-axis down the middle. This next one we are going to create, this one's going to be a quadratic. Now, since it says discrete, and I'm sorry, the last one said continuous, didn't it? Or did it tell me? It said continuous. Okay, this one says discrete, which means I am not going to draw a smooth line. It's going to have a maximum. That tells me that it's going to be, it has a minimum. That tells me it's going to want one of the ones that has the point at the bottom. So I'm going to go graph it. I'm not going to guess. I've written one. So I'm going to go make this 1/4 x squared, and we're doing a quadratic. I'm going to go delete a little bit. 1 divided by 4. I'm going to arrow out, put x squared, okay? There it is. If you look, it looks like it's a quadratic, and it looks like the minimum, the bottom of your quadratic, is at the origin. Now, again, they said it needs to be discrete. What you see in Desmos is always going to be continuous, but we don't really want continuous. So what I'm going to do is I'm going to put the 1 point, and then big hint, if you'll go click on that little settings wheel that's right above my equation and then click on table, I'm going to go get some points that I'm going to graph, okay? I'm going to go graph 0, 0 I did. I don't want to do any decimals. I want to stick with whole numbers. So I see 2, 1, and I know quadratics are mirror images, so I'd be willing to bet that if I had a -2, I'm going to go add -2 for my x. Look, it's also going to be at 1. So 2, 1, I'm going to go graph that right now. -2, 1. So there's some points. I want to get a few more points. Let's see if I can skip to like 4. Oh, look, 4, 4. Then I bet if we did -4, it's probably also going to be 4. Yep, it is. So I'm going to go over 4, and I'm going to go up 4, and I'm going to go left 4 and up 4. And I'm not going to connect this because it says it needs to be discrete. So do not connect the dots if they're looking for discrete. Okay? All right, the next one they wanted linear. So it's in that form AX plus B. So we've written one for you that we're going to type in. I'm going to go back to Desmos. I'm going to clear out the one that I have. And I'm going to put in 2x minus 1 because that's in that linear format. So 2x minus 1. Oh, look, it's a straight line. They want this one to be discrete as well. So I am not going to connect the line. I'm going to go get a few dots off of Desmos, and I will use just those dots. So I'm going to go draw my X and Y axis. If you want to go put an X and a Y, you can. Okay, I'm going to come back to Desmos, and I'm going to click on that little settings button and the table, and there are some points I can put in. Okay, check it out. Those are all whole numbers. Those are easy, or integers. So I'm going to do 0, -1, and by the way, I can see all these. Okay, any of these points. There's 0, -1. There's 1, 1, 2, 3, -1, -3, -2, -5. I'm going to go write those on my graph. Okay, so I'm going to start out with 0, -1. And then I'm going to do 1, 1. I'm going to do 2, 3. And then I'm going to come do my graph moved just a little bit. -1, -3. My pen's dying on me. Sorry, guys. Right there. -2, -5. I can keep going, but I'm not going to. But you guys can see that those points are all in a line. Again, I need it to be discrete. It is going up, and it's a function because my x's don't repeat. So I did well. Okay, this next one, we want it to be continuous. So this time I'm going to connect the points. It's going to have a maximum. That means it's going to look like this. It's a function, and it's going to be a quadratic. So again, it's going to look kind of like that curve shape. So I'm going to go type this one in. -x squared. Okay, there it is. It looks like it goes through the origin as well. Since it's going to be continuous, you know, you might want to know where some of the points are, but I'm just going to connect the line. And this one's already got everything on the graph, which is nice. I'm not having to draw it in there this time. So looks like I've got the points. Let's see, what are some of these points? -2, -4. I've also got 1, -1, -1, -1. So it looks like this, and I am going to connect it because they want continuous. Okay. Last one, they want me to find one that is, it's going to be not a function. Guys, not a function means it has to fail the vertical line test when you're looking for it, okay? It must fail the vertical line test. Now, it's a straight line and it's continuous. And so what that means is it's going to have to be going up and down, okay? Well, an equation like that is going to start with an x because it's going to run along one of your x lines. So we've come up with x equals 3. And if you look, I'm going to draw a table for this one. Oops. Oh, it won't let me do a table. So all of the points along this line, if you follow my finger for what's on the screen here, every single point on this line has the same x value. I go up higher, I can be down lower. They all have x equals 3. So that fails the vertical line test. So I'm going to go ahead and just draw, and it says it wants this to be continuous. So I'm going to draw it just like that. There you go. That fails the vertical line test. Okay. Not going to do the rest of these. There is a lesson 4 assignment that you can go and do some practice and look at this one. For example, this one's a quadratic. it decreases, then increases. It's drawn as a continuous. This next one, linear, it's continuous. The next one is exponential, continuous. This last one on this page looks like it's linear and it's continuous. And you're just going through and just identifying some other key features on those graphs. Okay, that's it for today's lesson.